So here we see that in parallel combination, let's suppose these two resistors are in parallel. So their equivalence resistance means we can replace these two resistors with a single resistor that can do the job of both the two resistors. So this equivalence resistance can be found by, let's suppose this equivalence resistance is having the value as Req. Eq is basically equivalence resistance. Okay, so it is denoted by Req. So let's suppose Req is the equivalence resistance of both the two resistors in parallel combination. So 1 upon R equivalence Req, 1 upon Req is equal to 1 upon R1 plus 1 upon R2. Now let's suppose there are more resistors in parallel combination. So again we will be adding, like let's suppose if R3, R4, R5 are there. So we will just write it that 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 and so on. Right? Similarly, let's suppose if there are more resistors, more than 2 resistors here. So the equivalence resistance of all the resistors in series combination will be found as R equivalence is equal to R1 plus R2 plus R3 plus R3 plus dot 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 and so on. Right? This is basically the equivalence resistance of series combination is the simplest one. Right? Whereas in parallel combination it is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 dot. Now the point is, when you find out the value, right, means 1 upon R equivalent is equal to 1 upon R equivalence is equal to 1 upon R1 plus 1 upon R2 plus dot dot dot. So after taking the reciprocal of all these resistors and then adding them, so 90% of the student who don't have the proper idea, they think that they have found the equivalence resistance, which is not the equivalent resistance. It is basically the reciprocal of your equivalence resistance, means your answer. So what do you have to do? After getting the final value of 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 1 upon Rn. So once you get this sum, so then again you have to make 1 upon that sum, right? Means you have to find the reciprocal of that value which you have got. So after taking the reciprocal, only then you will find the R equivalence. Are you getting? If you leave it like that, so marks will be deducted and that will be a wrong answer. Means let's suppose if the answer that you are getting after adding 1 upon R1 plus 1 upon R2 plus 1 upon R3 is 5 by 6, let's suppose. So 5 by 6 is not your R equivalence. That is basically 1 upon R equivalence. So you need to again take the reciprocal of that. So after taking the reciprocal, you will get your final value of the equivalence resistance of all the resistors which were in parallel combination. Are you getting? So I hope you must have understood that how to find out the equivalence resistance of two kinds of combinations of resistance that we call a series combination and parallel combination, right? Now we will do a lot of numerical problems to identify, so that how can we do that, how can we apply the formulas, and how the problems of combination of resistors are done, right? Till then it's okay for now, and wait for the next lecture. So we will be doing a lot of numerical problems based on the combination of resistors. Okay, thank you, take care, bye bye.